What's up everyone, welcome back. Patrick here. Moving on to the next video, we're now going to talk about the 68, 95, 99.7 rule for the normal distribution. Sometimes you'll see certain textbooks call this the empirical rule for the normal distribution, so both of them mean the same thing. Now in the previous video, we talked about how a normal distribution is what? It's basically a density curve that has three characteristics. So it is symmetrical, it is unimodal, or it has a single peak, and then we also said that it is bell-shaped. And then we also mentioned that it's fully described by two characteristics. So one characteristic deals with the central tendency of the normal distribution, and we describe it by the mean, and a lot of times you'll see it symbolized as mu. And then it's also described by the variability, and more specifically the measure that we're going to be using for variability with a normal is the standard deviation, and that's usually symbolized with a sigma. And we also talked about how this variability really affects the shape of the normal distribution, just visually. So if you got low variability or a low standard deviation, then what's going to happen is you're going to have a normal that looks like this. So the mean is always in the middle, but because it has low variability, all of the data is going to be concentrated more within one area. It's sort of a thinner normal distribution, versus if you got high variability, that data is going to be more spread out. So high variability or a higher standard deviation. So the normal will then look more so like that. So you're going to have the mean in the middle, and then it's going to be more spread out. And notice how both of these are a normal distribution. Both of them have an area of 1 under them, right? They're both density curves, and they both have these three characteristics, but they do look a little bit different. Again, this one's more spread out because that variability is higher, that standard deviation is higher. So now what this rule does here, this empirical rule, is it relates both of these, the mean and the standard deviation, in a more technical way. And what the rule states, so basically let's say for a normal with a mean of mu and standard deviation sigma, so we're going to keep it general for now, there's basically three cases that can happen. And by the way, sometimes they won't give you the characteristics of this normal in words like that. So sometimes they may represent a normal with a bracket, and they'll put the mean here and then the sigma. Lots of textbooks do it like that. So instead of saying a normal with a mean of 10 and then a standard deviation of 3, sometimes they'll just put an n and they'll put a 10 and 3 like that. Right? So sometimes a normal will be described by words, sometimes it will be in this notation. Let's keep it in words for now. So a normal with a mean mu and standard deviation sigma, the first case is that 68% of the data, actually, you know what? It's not always exactly 68, it's approximately. Very close approximation though. Approximately 68% of the data falls within one standard deviation of the mean. Okay, approximately 68% of the data falls within one standard deviation of the mean. And so another way to say that is 68% of the data is going to be in the interval mu, the mean, plus or minus 1 times the sigma, 1 times the standard deviation. Or another way to write this is that 68% of the data is going to be between mu minus sigma, this number, whatever it's going to be, and mu plus sigma. Okay, so for example, let's say that we have a normal that has, let's say, a mean of 14 and then a standard deviation of 3. Well, if we draw this out, remember a normal, it's always going to be symmetric like this. So the mean is always in the middle. Well, if we subtract one standard deviation and add one standard deviation, we would end up with 11 and we'd end up with 17. This should be symmetrical. Perhaps not as symmetrical in my drawing. So what this means is that for this specific normal here, approximately 68% of the data is going to be within that interval between 11 and 17. Okay, because we got the mean minus 1 standard deviation, 14 minus 3 is 11, and then the mean plus 1 standard deviation, 14 plus 3 is 17. So 68% of the data is going to be in that interval. Now, what about these remaining areas here in the normal distribution? So we got this 68% covered here. And if you remember, the whole area under a density curve is always equal to 1, but in this case, we're dealing with percentages, so it's going to equal 100. So if 68% of the data is covered here, then what's the remaining area? Well, it's going to be 100 minus 68, which is 32%. And because this is symmetrical, it's a normal distribution. Remember, a normal is always symmetrical. That remaining 32% area is going to be split evenly between these two areas. So this here is going to be 16%. And this here is going to be 16%. So when you add 16, 68, 16, you would end up getting 100%. And given this, with this specific normal here, you can start making certain statements. So you can say that 68% of the data is in between 11 and 17. Right? But you can also start making other statements regarding these other areas. So you could say 16%, approximately 16% of the data is greater than 17. Right? Or 16% is less than 11. That's another possibility. Or you could even combine these two areas. So we can say that if I take 68 and I add 16, that would give us 84. So approximately 84% of the data is less than 17. Right? From here all the way to over here. Right? 68 plus 16. Or 84% of the data is greater than 11, this plus that. So with these different areas, you can start making different kinds of statements. Right? So that is the first case of this rule here, of this empirical rule. Now, the second case, as you guessed it, instead of 1 standard deviation, we're going to be dealing with 2 standard deviations of the mean. And within 2 standard deviations of the mean, 95% of the data is there. So approximately 95%, this is the second scenario. So approximately 95% of the data falls within 2 standard deviations of the mean. Or we could say in the interval mu plus or minus 2 times the standard deviation. Or we could say between mu minus 2 times sigma and mu plus 2 times sigma, like that. So let's make an example. You know what? Actually, let's use the same one. So sorry, we had 14 and 3, like that. So if we draw the normal again, we'll have 14. I'm going to kind of put these closer together now. So this is going to be within one standard deviation. So this is still going to be 17. This is going to be 11. But now we're going another standard deviation out. So we would take 17, add 3, which would be 20. Then we're going to subtract 3, which is going to be 8. Okay, so now notice we got the mean here of 14. And we subtracted 2 standard deviations. So 2 times 3 is 6, 14 minus 6 is 8, 14 plus 6 is 20. And so within this area here, all of this, so between 8 and 20, 95% of the data falls. Okay, and then these remaining areas, the total remaining area is going to be 5%, 100 minus 95, but then it's split evenly between these two areas. So this is going to be 2.5, and this is going to be 2.5, like that. Okay, so with this, you could start making statements. So 95% of the data falls between 8 and 20, or we can say 2.5% of the data is greater than 20, 2.5% of the data is less than 8, or we could say 97.5% of the data is greater than 8, or we could say 97.5% of the data is less than 20. We can make different statements. Okay, so within 2 standard deviations of the mean, 95% of the data falls. And then finally, the third case is 99.7 within 3 standard deviations. So approximately 99.7% of the data falls within 3 standard deviations of the mean. So this here would be a 3. This here would be a 3. This here would be a 3. So let's maybe use a different normal. So let's say we got normal with a mean of 40, and then we got a standard deviation of 5. So if we draw normal with these parameters, what we're going to have is 40. I'm going to keep it a little compact here just to show all 3 standard deviations. So the first standard deviation would be 45, 35, right? 40 plus 5, 40 minus 5. 2 standard deviations out is going to be 50, 30, and then we're going to have 25, 55. Right? So 3 standard deviations to the left of the mean of 40. Remember, this is the mean here, and to the right of that mean. Okay, so if we kind of block these out, so basically this whole area here is going to be 99.7%. And the percentage remaining is 0.3% divided by 2, so this would be 0.15%. This would be 0.15%. Right, so for a normal with these parameters with a mean of 40, standard deviation of 5, approximately 99.7% of the data falls between 25 and 55, or 0.15% of the data is greater than 55, or 0.15% of the data is less than 25. We could add these as well, right? So approximately 99.85% of the data is greater than 25, or 99.85% of the data is less than 55. So again, different statements that we can make. Sorry, this is the third case here. Forgot to change that. Okay, so that pretty much is that empirical rule for the normal distribution. Basically 3 cases that we're dealing with, whether we're going 1 standard deviation from the mean, 2 standard deviations, or 3 standard deviations.